Chemical changes are represented by chemical equations. When you have a chemical change, you have in the beginning substances with specific properties, and at the end of a chemical change or after a chemical reaction happens, you're going to have new substances with different properties than the substances that you had in the beginning. A chemical equation is represented by the reactants on the left side of an arrow and the products on the right side of an arrow. You can have one reactant to products, you can have two reactants to products, two reactants, one product. The amount of reactants and products is going to be determined by the specific type of reaction that you have. An example of a reaction is the one that I'm giving you here, where you have magnesium as a solid, and magnesium as a solid reacts with hydrochloric acid to form magnesium chloride and hydrogen gas. Whenever you have hydrogen gas or any gas as a product of a reaction, you will see the gas formation by the presence of bubbles. So whenever we want to identify if a chemical change is happening, if you get to see formation of bubbles, it means that a gas is forming in that specific reaction. Other types of observations that you can use to determine if there's a chemical change happening is a color change. And that color change is not just based on a dilution. If you have a solution of a specific color and you add more water, the color will look lighter, but that's not a chemical change. That's just a physical change because of the addition of more water to your solution. So formation of bubbles, color change, and then we have number 3, which is formation of a solid. So sometimes when we mix two solutions together, those solutions are aqueous solutions, and one of the products that you get out of the reaction that is happening, it's a solid. That solid is called a precipitate. We have solubility rules that we can use to identify which product in a chemical reaction is a solid. The formation of a precipitate, it's indicated that one of your product is going to be an insoluble compound in water. Then we have number 4, which is change in odor. So if you can determine like a specific smell coming out of a reaction, that can also indicate that you have a actual chemical change happening. Another thing that we can check is for changes in temperature. But what happens with temperature is that a temperature change can represent a physical or a chemical change. It's not specific for chemical changes. You can have things like specific compounds that are soluble in water that when you put them in water or when you dissolve them in water, you will get a temperature change. So your temperature changes can represent chemical or physical changes. I have two examples here, like as an example for a physical change where you can notice a change in temperature is the dissolution of ammonium chloride in water. Ammonium chloride is a solid at room temperature, but it's soluble in water. So when you put ammonium chloride in water, you can prepare a solution because your ammonium chloride is going to dissolve. The process for your ammonium chloride to be able to dissolve into the ions, it's a process that is endothermic. When you have an endothermic process, what happens is that your actual process requires energy or heat for that process to happen. So for your ions in ammonium chloride, for that ionic bond to break apart so you can have your positive and your negative ions in solution, that ionic bond requires amount of heat or energy to break apart. So whenever you have an endothermic process, the temperature change that you can actually feel. If it's an endothermic process, you will feel the temperature decreasing. The container where that process is happening, it will feel cooler. The temperature will go down because your actual process requires energy and it will absorb energy from the surroundings, and you will be able to feel that temperature change. So ammonium chloride dissolved in water, it's an example of a physical change. It's just the dissolution of a solid compound. If you actually evaporate the water, you will get your solid compound back again. Now, as an example for an exothermic process, I can mention neutralization reactions where you have a mix of an acid and a base. So mixing an acid and a base will result in a neutralization reaction where the product is water, and neutralization reactions are usually exothermic. Whenever you have an exothermic process, you can actually feel the temperature of your container increasing. It will feel warmer. The neutralization reaction is an example of a chemical change. If you're mixing an acid and a base, you're getting water as a product. So you're going from your initial substances to new substances with different physical and chemical properties. Now, there are many different types of chemical reactions, and we classify them into categories. So we have synthesis reaction, decomposition, single replacement, double replacement. So for synthesis reaction, what we have is different substances that are combined to give you one new substance. So you go from more than one to just one. And in general, you have elements combining to form new compounds. In the composition reaction, it's kind of the opposite of the synthesis reaction. For the composition, you have one substance that is being decomposed into simpler substances. So you have a compound being decomposed into its elements, or a compound like the example that I'm giving you, um, carbonic acid here that forms water and carbon dioxide. In that specific reaction or that specific example that we have in number 2, the formation of carbon dioxide will be noticeable because you will be able to see bubbles forming into the container. Now, number 3 is single replacement. This is an example. In this type of reaction, you have an element in a compound that is going to be replaced by another element. So you have here aluminum reacting with silver sulfide, and you're forming silver by itself. So you can see how the aluminum is replacing the silver in that compound silver sulfide. Now as a product, you will have your aluminum sulfide and silver as the element by itself. So it's one element replacing another element in a compound. And then for number 4, double replacement, your ions are being exchanged. So for example, I have here an example of a neutralization reaction, which is an exothermic reaction where you have hydrochloric acid reacting with sodium hydroxide, acid and base neutralization, and you get water as a product and sodium chloride in that specific example. So you have a double replacement because as you can see, the H in your hydrochloric acid is replacing the OH in your sodium hydroxide, and then the ions that are left, your sodium and your chloride, are combined to give you the second product. So you're getting the water and sodium chloride. A lot of reactions where you actually have formation of a precipitate are double replacement reactions. Number five, another category for chemical reactions are combustion reactions. So you have a reaction with a substance reacting with oxygen gas. So you can have like carbon reacting with oxygen to form carbon dioxide. Another example is metals reacting with oxygen to form the oxide of the metals. So in that specific example, I have magnesium and oxygen reacting to form magnesium oxide. Combustion reactions usually produce heat and light as products also. So you can actually feel a temperature change in this type of reaction. Some of them you will see actual light, like for example that magnesium reacting with oxygen. If you burn magnesium, you will be able to see light coming out of the reaction, and then you get the product magnesium oxide. So for the procedure, I'm going in part 2, letters C through L. You have to use gloves and safety goggles at all times. And what you have to do is to observe and copy your observations. You're looking for color changes, formation of a solid. Sometimes when you have formation of a solid or a precipitate, you will be able to see like a formation like a cloudy solution, not just like a big piece of a solid. So that's something that you need to check. Color changes. If you have formation of a solid, you need to write down like what color do you have for that specific solid. Formation of bubbles, that means that a gas is being formed, and when we're writing the actual equation, we can determine which gas was formed in that specific reaction. If there's no reaction or you don't get to see um, anything happening, you can just write down no reaction. But always remember that if you have a temperature change, you should be able to feel the temperature changing. You will not be able to see it. And so you can feel the test tube where the reaction is happening to determine if the test tube is becoming cooler or warmer. So for letter C, you're going to add 2 milliliters, and 2 milliliters is about 40 drops of distilled water into a test tube. So for all of the different chemical reactions or the mixtures that you're doing, you need 2 milliliters. So you can measure the first 2 milliliters, and then you can use that test tube with the 2 milliliters to add the other amounts. So you don't need exactly 2 milliliters or exactly 40 drops. Okay? There's nothing quantitative happening. This is all observations. So you don't have any numbers, and you don't have to actually worry too much about getting a specific amount of a substance. So 2 milliliters of distilled water in a test tube, and then you're going to take a piece of zinc, and you're going to drop that piece of zinc into the test tube, and you're going to see if anything happens. You're going to record all of your observations. For letter D, you're going to do the same, but now you're not using 2 milliliters of distilled water, you're using 2 milliliters of hydrochloric acid with a concentration equal to 3 molar. So make sure that you check the label, that it's hydrochloric acid, and the concentration is the correct one. For letter E, you're still using 2 milliliters of 3 molar hydrochloric acid, but now instead of adding zinc, you're adding copper. So we have already 3 test tubes with 3 different possible combinations. For letter F, you have 2 milliliters of iron chloride, and to those 2 milliliters of iron chloride, you're adding 3 drops of potassium thiocyanate. And letter G, you're going to add a small amount of sodium bicarbonate into your test tube. A small amount is the tip of a spatula, the smallest one that you have. A small amount, make sure that you have gloves for this one, because sometimes it will come out of the test tube. That you have like paper towel on top of the table just in case if you spill something, that it will get on the paper towel. So a small amount of your sodium bicarbonate, and now you're going to add 2 milliliters of acetic acid. Record your observations. In that letter G, that combination, it's going to give you actually two reactions. They're consecutive reactions, so you're getting your products first, and then your products are giving you different products, so it's two different ones. For letter H, you're going to have 2 milliliters of barium chloride in the test tube, and then to those 2 milliliters, you're adding 3 drops of sodium phosphate. In letter I, you have 2 milliliters of cobalt chloride in the test tube, and now you're going to add 10 drops of sodium hydroxide. Letter J, next one, we have 2 milliliters of silver nitrate in your test tube, and you're adding 10 drops of your 3 molar hydrochloric acid. In letter K, you're going to add 2 milliliters of potassium iodide into the test tube, and to those 2 milliliters, you're going to add 10 drops of sodium phosphate. And the last one, you're going to have 2 milliliters of sodium hydroxide into a test tube, and to those 2 milliliters, you're going to add 2 milliliters of your 3 molar hydrochloric acid. Whenever you're done mixing all of your substances in your different test tubes, make sure that you have all of your observations in your lab manual, that you write down if it is formation of a solid, that you write down the color of that solid. If you're seeing bubbles, that you're writing down that you have formation of bubbles, temperature change. If there's no reaction, just write down no reaction. So when you're done with everything, you can collect everything into a beaker and use that beaker for all of your waste that you have in your bench. Collect all of your waste in that beaker and then go and transfer that waste into the waste container. Clean everything, all of your test tube droppers, anything that you use, clean everything and return everything to the original location.